Hi there, my name is Yvonne. In this tutorial, we will be discussing search. But first, what is search? Search is an operation or method of finding the place of a given element or value on the list. Search has three types: linear search, binary search, and the improved variant of binary, which is the interpolation search. Let's talk about linear search first. Linear search is a searching algorithm wherein a sequential search is made over all the items one by one. To further discuss this, let me show you an example. For suppose, we take this array with the limits 1, 2, 6, 7, 10, 20, and 22. Now, let's say that we are looking for element number 10. And there are 7 elements in the array. What we are trying to do is to find the index of x. Obviously, we can see that 10 or the value of x is seen at index 4. Now that we know what we're attempting to do here, let's now discuss how to execute the program. Here are the steps in order to find the index of x using linear search. First, start from the leftmost element of the array, and one by one, compare x with each of the element of the array. If x matches an element, return the index. If x doesn't match with any of the elements, print element is not found. Let us look at the implementation. I implemented the program using Java, but you are free to use your language of preference. We simply run a loop that runs to the length of the array. Once we match the value of the array with the value of x, which is 10, we return I, or the index of the element in the array. If the loop finishes the array without finding the index of x, then it will return -1. When we execute the program, it should print the element is found at index 4. That is how linear search works. Now let's move on to the second type, which is binary search. Binary search is a fast searching algorithm that works on the principle of divide and conquer. For example, we have an array that has a value of 1, 2, 6, 7, 10, 20, and 22, and we used x again to represent the value that we are looking for. Let us say that x is equals to 10. In binary search, we start searching in the middle of the array, and if it's equals to x, then we're done. If the x is smaller than the middle element, we will look for it on the left half of the array, and if it is larger than the middle element, we will look for it on the right half of the array. We repeat this process again and again until there's only one element left. If that one element is equals to x, then the element is found. Here are the steps for finding the value of x using binary search. First, compare x with the middle element. If x matches with the middle element, we return mid-index. If x is greater than the middle element, then x can only lie on the right half subarray after the mid element. So we recur for the right half. Else, if x is smaller, recur for the left half. This is the recursive code of binary search using Java. Low represents the smallest index, which is 0, and high represents the largest index, which is here in the given array. High is 7. Mid represents the middle index. To compute for the mid, we use the formula mid is equals to high minus low plus low over 2. Again, if mid is equals to x, then the searching is done. If x is found to be smaller than the mid, then we will look for it on the left half, and if it's larger, then we will look for it on the right half until there's only one element left. If the remaining element is equals to x, then it will print element is found at index 4. and if the element is not found, it will print out element is not found in the array. Now that you've understand the binary search, let's move on to the last type, which is interpolation search. Interpolation search is an improved variant of binary search that works on probing position of the required value. For this search, we have this formula to find the x. After computing, we compare the element of m with x. If it is the same, then we are done. If not, then compare the element of mid with x. If x is found to be greater than the element of mid, then we break off the array from leftmost index to mid. If x is found to be less than the element of mid, then we break off the array from the rightmost index to mid. Then we assign the new value of low and high. We repeat this procedure until the mid is matched with x. The following are the steps for implementing binary search to determine the value of x. In a loop, calculate the value of mid using probe position formula. If it is a match, return the index of the item and exit. If the item is less than the array, calculate the probe position of the left subarray. Otherwise, calculate the same in the right subarray. Repeat until a match is found or the subarray reduced to 0. This is the implemented code using interpolation search. Like binary, interpolation repeats the process if the element of mid is not yet matched with x. When the x is found, the program will print out element is found at index 4. If the element is not found, then the program will print out element is not found in the array. That's all for searching algorithm. I hope you learned something new today. All the reference will be posted on the description below. If you like my video, please hit the like button. This is Yvonne, signing off.